Hello, dear students. I am here, LALITKUMAR P BHAIYA, Associate Professor, Department of Electronics and Telecommunication Engineering, Bharati College of Engineering and Technology, Durg. Dear students, today we will go through the last part of this multi-stage amplifier, that is Darlington pair. Till now what we have seen, I will just go within a minute and later on I will explain about the Darlington amplifier. This multi-stage amplifier we have already seen in the very first video of the multi-stage amplifier. What are the effects of these we have seen. What is the need of the multi-stage amplifier that we have seen. The overall voltage gain and overall current gain that we have seen. The coupling of the stages, between the two stages that we have seen, direct coupled, transformer coupled, cascode amplifier. And the remaining part, numerical also we have seen. The remaining part is the Darlington pair that we will go through this point. Impedance matching can be solved by using the transformer coupling between the two stages. We can achieve the impedance matching. We can get the proper frequency response in RC coupled amplifiers. Similarly, with the help of the DC amplifier, direct coupled amplifier, we can get the DC isolation. This RC coupled we have seen two stage. This is the equivalent circuit that we have seen. The first stage AV1 and AV2 we have calculated already in the last slides. And this example also we have seen. So no need to tell again here. This is first just a review what till now we have seen. Now this direct coupled amplifier we have seen, the example also of the direct coupled amplifier. This what is the effect of the fluctuating temperature we have seen. This is the direct coupled amplifier which we have seen. Transformer coupling, this type of we have seen between the two stages. And this impedance matching can be done with the help of this turn ratio, that also we have seen. And cascode connection, I have already presented the one video on this cascode connection particularly. So that we have seen, that is CECB stage is the cascode connection. And now come to this Darlington pair. A very popular connection of the two bipolar junction transistor for the operation as one super beta transistor is the Darlington connection as shown in figure below. Later on we will go figure below. Why it is called as super beta? Because the value of the beta can be achieved highest in case of this Darlington pair. The main feature of the Darlington connection that the composite transistor acts as a single unit with a current gain that is the product of the current gains of the individual transistor. I have already told you about super beta. So beta 1 and beta 2 are the two current gains of the transistors. Then beta square can be achieved here. Here it is written, you can see, if the connections is made using two separate transistors having current gains of beta 1 and beta 2, the Darlington connection provides a current gain of, let us say, beta D, that is equal to beta 1 and beta 2. That's why it is called as a super beta transistor. And this is the connection of the Darlington pair. You can see here, this is the common collector connection. Output is taken from the emitter, and again you can take the output from the emitter. So this transistor of this Q1 and Q2, connection of the Q1 and Q2 is called as the Darlington connection. This Darlington connection can be modified along with the external circuit, that is biasing circuit of the transistor. Beta can be beta 1 and beta 2, that is the product of the beta, and that's why this transistor having a great advantage providing the super beta in place of the, and this is also called as a multi-stage because two stages are required of the transistor. Therefore we can also say that this is multi-stage transistor. So this is about the Darlington amplifier where we can achieve this higher current gain. Here this circuit is shown for the three-stage amplifier where both the type of transistors are used, that is FET transistor and this transistor. These two stages, this is the common collector stage, this is the common emitter amplifier, and this is the common source amplifier. This is the source resistance and source input, and this is the load resistance and output. So more than two stages we can connect also. See, and different transistors can also be connected in the multi-stage amplifier. That is the transistor common source amplifier, transistor 1, transistor 2. So this type of connection may also be possible using the transistors. So here in your syllabus, no need to go for the 3-stage amplifier, only up to 2-stage amplifier and their calculation of current gain, voltage gain with source, current gain with source, and the input impedance and output impedance. These parameters are important for the 2-stage transistor. And lastly, I have to show the one more thing here. This is the characteristics of the 2-stage RC coupled amplifier. Here you can see this is one of the cutoff frequency, this is another higher cutoff frequency. Between these two cutoff frequency, the difference is called as a bandwidth, and within this bandwidth we will get the constant output. And this is why this characters I have to show these characteristics as an important factor here, or important figure. This characteristics in RC coupled stage is obtained either in 2 cascaded stage or in 3 cascaded stage to get the better bandwidth. In better bandwidth and better amplification, we can achieve using the 2 stages or 3 stages of the RC coupled. So in RC coupled, this type of characteristics is important to get the large bandwidth. But in case of the transformer coupling, we will get the resonant frequency, because resonant circuit is used in the transformer coupled amplifier, inductor and the capacitor. Therefore, we will get something like this resonant frequency and like this. So this type of characteristics is not possible in case of the transformer coupled amplifier. So dear friend, you can go through these details of the multi-stage amplifier. Please go through this video as well as the channel of the Bharti group Swarnakar sir, as well as you can go through the notes and recommended books for this particular subject. Thank you very much. Next time we will see the next video. Thank you very much.